So let's start this chapter, and that is your haloalkanes and haloarenes. Just wait a minute. So first I'm going to do the introduction part, which is very easy, and I'm going to ask some questions. Are you aware of this halogens? Very easy questions. What is halogen? Mom and Austin.
Like chlorine, iodine.
Okay. Halogens, basically, it is the 17th group element. 17th group elements are also called halogens. And in short form, we use halo. So how many elements, basically, which elements are present in 17th group? That is your fluorine, chlorine, bromine, iodine. Astatine is also there, but we don't study about this. This is a radioactive element. So whenever I will ask you what is halo means or halogen, that means basically fluorine, chlorine, bromine, iodine. And generally, this halogen is represented by X, that is halogen. This halogen generally represented by X. Is that clear, both of you?
Yes, sir.
Okay. Now, I think you are aware of this alkane, alkene, alkyne from the previous class 11th as well as 10th, which is hydrocarbon, alkane, or we say alkyl group. Alkyl group. What is the difference? If I'm going to write CH4, this is your, you know that one carbon is called meth and CH4 is called methane. And if you are going to remove one of the hydrogen, that means it becomes CH3, and the bond carbon that make to satisfy itself is 4. And if you just removed one of the hydrogen, so one of the bond of carbon is free. Now it is called methyl. Are you getting my point, both of you?
Yes, sir.
Yes.
And if there is C2H6, C2, are you aware that I'm going to ask you some basic question. If number of carbon, I'm going to write here, number of C, that is carbon. If number of carbon is 1, that means meth. If number of carbon is 2, that means eth. If number of carbon is 3, what it is called? Do you remember? Can you repeat?
Prop.
Wrong. Mom, what about you? Tell me about the number of carbon 4. Humam, this question is for you. If number of
Butane.
carbon, can you repeat?
Butane.
Not butane. For only I'm asking about the number of carbons. So you are going to write but. Okay. For
Okay.
5, it is pent, and for 6, it is hex. For 7, what it is? Hap. For 8, it is oct. For 9, it is non. And for 10, it is, just wait a minute. For 10, it is dec. For 10, it is dec, right? Now, on the basis of the situation or the compound, if it contains single bond, the name ends with ane, that is alkane. If the, just wait a minute, highlight. Okay. So basically, if it is single bond, then the name ends with ane. And if it is double bond, the name ends with ene. And if it is triple bond, the name ends with ine. Is that clear, both of you?
Yes, sir.
So this is some basic things that we need to take care. And also this alkyl group has a representation, and generally we do represent this with R. So if I'm going to write Rx, so basically this Rx is alkyl halide. What we say? Alkyl halide, or we can say haloalkane. Haloalkane, or we can say haloalkane. Is that clear, all of you?
Yes.
Yes, sir.
Now, I am just clearing the name of the chapter. Haloalkane. What is exactly haloalkane is? Basically, this alkyl halide, we call it common name. This is your common name, and this haloalkane, you can consider this as IUPAC name. Now, the another name of the chapter that includes haloarenes. Haloarenes. Just wait a minute. Are you able to see the screen?
Yes, sir.
Now, see, this is your haloarenes. So, halo, you already know X. Arene, that I need to explain. Arene is basically benzene ring. So, generally, we represent it by AR or pH. So, basically, if AR, that means benzene is connected with any halogen, that is haloarenes. And if any alkyl group is connected with halogen or halogen is connected with alkyl group, that is your haloalkane. Is that clear, both of you?
Yes.
Organic chemistry is very, very important as it has weightage. Just no. So basically, what I wanted to tell you is that this is your benzene and this is your and it is represented by AR. That is that's common name is arene. I would like to ask you some questions. Do you know how to calculate or find degree of carbon? Yes or no? Do you remember it still or you have forgotten? Degree of
Primary.
carbon.
Is it like
Okay,
primary?
I'm gonna actually, yeah, it is like that. I'm gonna ask you some questions. Just okay. Humam, will you be able to tell me what is the degree of this carbon?
1.
1 degree. How did you calculate this? Basically, a carbon which is directly attached to another carbon, to how many number of carbon, that will be the degree of that carbon. So if you want to calculate the degree of this carbon, you need to check to how many carbons this carbon is connected. So it is connected with only one carbon, so it will have 1 degree, and 1 degree is also called primary carbon. Now, can anyone tell me what is the degree of this carbon? Austin?
No, secondary.
3 degree it will be, and 3 degree is basically tertiary. We call it tertiary. How it is 3 degree? So you can see this carbon is directly connected with this carbon, first carbon, 1 carbon, 2 carbon, and 3 carbon, directly attached with 3 carbon, and hence it is tertiary. Are you getting my point? Umam and Austin?
Yes, sir.
Now answer me again. What is the degree of this below carbon? The one which is on the bottom?
Primary.
Primary, that is 1 degree. What is the degree of this carbon? Any one of you?
2.
2 degrees, so it is secondary, also called secondary. So basically, the degree of carbon, to calculate the degree of carbon, it's very easy to calculate the degree of carbon. We just need to see how many carbons it is directly attached. So that will be the degree of carbon. Now the next question, which is very important, how to calculate. You are going to write here how to calculate degree of carbon. Degree of carbon is equal to how many carbon a carbon is directly attached. Are you getting my point? Directly attached. Is that clear, both of you?
Yes, sir.
Now, how to calculate degree of halogen? Degree of halogen. How we calculate basically the degree of halogen? So see, it's very easy. How you are going to find it? So if you have a structure CH3, CHX, and then comes here CH2, and then comes your CX, and then there is CH3, and then there is CH3. X is basically your halogen. If you want to calculate the degree of this halogen, you need to calculate the degree of carbon to which this halogen is connected. Are you getting my point? Degree of halogen, degree of halogen equals to degree of carbon to which halogen is attached directly, to which halogen is attached directly. So these are some basic concepts that you have studied in class 11th. So can you tell me the degree of this halogen will be?
Secondary.
Secondary. It is secondary. Can anyone tell me the degree of this halogen?
Tertiary.
Tertiary it is. You just need to calculate the degree of carbon to which this halogen is attached, and this is how you calculate the degree of halogen. And you know what, in the next chapter, that is alcohol, it is also the same way to calculate the degree of alcohol as well. At the place of halogen, if it is alcohol, we follow the same rule. Is that clear?
Yes.
Yes.
Now, can I change the slide or you are writing?
1 minute.
Yes.
Okay, take your time. Let me know when you are done with this. Power cutoff is there, so I'm switching off my video. Will that be okay?
Yes, sir.
Okay.
Done so.
Oh, sorry. We are going to do the classification, and classification, the first classification is on the basis of number of halogen atoms. On the basis on the basis of number of halogen atoms, number of halogen atoms. If there is one halogen atom, then what it is called? If there is two halogen atom, so as I told you, R is basically alkyl group, and for alkyl group I'm going to consider here in the first two carbons, so C2H5X, only one carbon X is there, so we can write mono halo, that represents only one halogen, so mono halo alkane. For the second one, you can see CH2X and then again CH2X. So since two halogen is there, so we can write dihaloalkane. 2X is there. Now for 3X, CH2X, CHX, and then CH2X. You can see three halogen is there. So for this, you can write trihaloalkane and so on. Are you getting my point?
Yes, sir.
In the same way, we can go for the haloarine. You can see this is your haloarine, this is arine, which is called benzene, and this is your X, that means haloarine. So since only one halo is there, so monohaloarine, monohaloarenes. Now you can go for this as well. If you have two halogen group X and X is here, so it will be dihaloarine, dihaloarine. And if you have free halo group, if you have free halo group, you can see if there is three halo group X here, and X here, so it is trihaloarine, and so on. If you have four, it will be tetra, and so on. Are you getting my point? So this, the first classification is on the basis of number of halogen atoms, on the basis of number of halogen atoms. Please do write it. Let me know when you are done with this. Let me know when you are done with this.
Done so.
Very good. Moving to the next classification, and that is on the basis of compounds containing sp3CX bond. X, you know that fluorine, chlorine, bromine, and iodine. Now, what does it mean? Basically, it has two parts. The first one is alkyl halide, and the second one, basically alkyl halide, or we call it haloalkane. That means RH. Basically, what does it mean? To the carbon which X is connected should be sp3 hybridized. That means to the carbon to which X is connected should be singly bonded. All the bonds should be single. So this is your C, this is your X, this is your hydrogen, this is your hydrogen, and this is your R. R means alkyl group, that means carbon containing group. So this carbon is only connected with only one carbon containing group, and hence it is your primary. It is your primary. And accordingly, if you have two carbon containing group, so it will be known as secondary. And in the same way, you can go for this. If all are connected with a carbon containing group, then this is your tertiary. Are you getting my point?
Yes, sir.
So basically, we did write the degree of halogen. So compounds containing sp3CX bond, in which the first is known as alkyl halide or haloalkane, and in this way we divided this. We categorized this. Please do write it. Let me know when you are done with this. Done with this?
Done, sir.
Very good. Okay. Now the second classification on the basis of this is the second classification B part is your allylic halides. Allylic halides. This is also the part of sp3x. That means to the carbon X is connected should be sp3 hybridized. What does this means? Basically, there is a condition in this CH double bond CH and then comes CH and then CH2X. Basically, to the carbon X is connected must be sp3 hybridized and adjacent carbon should be doubly bonded. That means sp2 hybridized. So this kind of scenario is known as allylic halides. In the same way, you can go for this. You can see this is your cyclohexene and you can see this is your X here. So to the carbon to which X is connected is sp3 and adjacent carbon is 2 here and here, and this is also sp3. So on this side it is not allylic, but on the right hand side if you will check it, it is doubly bonded. That means sp2. So this is your allylic. The system is allylic halide. Are you getting my point?
Yes, sir.
And this carbon sp3 carbon to which sp2 carbon is connected is called allylic carbon. Sometimes the questions will be asked which of the following is allylic carbon. So this sp3 hybridized carbon is called allylic carbon. You can get another example like this: CH2 double bond CH and then CH2 and then X. You can see to which X is connected. This is your sp3 and adjacent carbon is sp2. So this is your allylic carbon and this is allylic system. Very easy. Let me know. We have another classification inside this. It has 3 parts. Let me know when you are done with this. Both of you done with this?
Done, sir.
Okay, Humam.
Yeah,
Now
done.
the C part is basically benzylic halide. Benzylic halide. What is this benzylic halide? Since it is the part of the same, so to X basically to the carbon to which X is connected should be sp3, and since benzylic that comes from benzene, you can see this is your benzene. So you can see that adjacent to this sp3 hybridized carbon, it is sp2. Are you getting my point? I'm going to again draw the diagram since it is not looking correctly. So this is your scenario. Let me erase this. Now you can see this is your sp2 hybridized and this is your ch2x. So basically this is your sp3 and this is your allylic carbon, benzylic carbon. This is your benzylic carbon. What we call it? Benzylic carbon. And you can see this is your sp2 hybridized. So this system is basically known as benzylic carbon. And if there will be question, what is the degree of this halogen? So this halogen will have primary. This halogen is primary 1 degree, because to the carbon this halogen is connected is only 1 degree. That's why. In the same way, we can have another benzylic halide in this way: CR, R dash, and then X. So you can see this is your again sp3 and adjacent carbon is doubly bonded. So this is your benzylic carbon. And if you go for the degree, it is tertiary, or we 3 degree, or we can write tertiary halide, because you can see to the carbon this X is connected with 3 carbon. So this is your 3 degree carbon. That's why it is tertiary halide. Got it?
Yes.
Yes.
Please do write it. Are you done with this?
Yes, sir.
Okay. Now, the next classification, the third classification on the basis of, just wait a minute. Let me know when you are able to see the screen. Are you able to see the screen?
Yes.
Okay, the third classification is basically compounds containing sp2CX bond. X, you know that is your halogen, fluorine, chlorine, bromine, and iodine. And it is directly has been written that it has been directly said that to the carbon X is connected should be doubly bonded or sp2 hybridized. That means CH2 double bond CHX. So basically, this scenario is your this is called vinylic halides. This is called vinylic halides. This system is called vinylic halide. Very important. What is allylic halide? The carbon to which X is connected is sp3 hybridized, and adjacent carbon to that sp3 hybridized carbon should be doubly bonded or sp2 bonded. And here, what is vinylic halides? This is the scenario CH2 double bond CHX to the carbon to which X is connected should be doubly bonded. Or you can write as well this is your double bonded. So X is directly connected to the doubly bonded carbon or sp2 hybridized carbon. That is your vinylic alcohol. And in the second one, you can go for aryl halide. In the previous one, it was benzylic halide, and this is your aryl halide. And aryl halide is part of this sp2CX. That means X is directly connected to doubly bonded carbon. Doubly bonded carbon. Are you getting my point? This can also be called doubly bonded aryl halide. Got it? Both of you.
Yes.
Yes, sir.
So you are going to make this introduction part very strong because because this introduction will be repeated in the alcohol as well. There you will study vinylic alcohol. The system will be same, only X will be replaced with OH. Aryl halide, there will be phenol, that is called a special type of compound, phenol. If there will be allylic halide, that will be known as allylic alcohol, and this X will be replaced by OH. So please make sure you are going to make this basic very strong so that there will be no problem in the next chapter. If you are going to make your this chapter very strong, then more than 50% reactions you will be able to understand easily from the next chapter. Are you getting my point?
Yes, sir.
Okay, please do write it and let me know.
Done, sir.
Very good. Okay, how's your nomenclature? Since in this chapter the nomenclature part is very easy. So will you be able to write the nomenclature of some easy questions or compounds? I'm gonna give you
Revision
from
is
NCERT.
needed, sir.
Can you repeat it again?
Revision for nomenclature.
Oh, it's very easy. First, you are going for the uh, longest chain, and I'm going to give you some question, and then accordingly, I will give you the explanation. Okay. So I'm going to give you very basic question. Please do try, and if you are not able to do, just let me know, Humam. Austin, what about you?
Yes, sir.
Yes, sir. That means you know how to do nomenclature.
Yes, I do. I do.
Okay, no problem. Very good. And Humam, let me know if you're not able to do it. That's not a problem. Uh, we can do it together.
Okay, sir.
Yeah. Let me know when you are done with this. Very good, Austin. The first one is correct. The second one is also correct. The third one is also correct. And the fourth one is also correct, bromobutane. Okay, what about you, Umam? Are you able to solve this or not? Not a problem,
No,
just let me know.
not really.
Okay. Umam, whenever you are aware of this, right? How many, what is the name of number of carbon? Like if it is one, it will be meth. It is two, eth,
Yes, sir.
three, but. So whenever you, this is your carbon chain, this is your carbon chain. Okay. Now,
Okay.
this is your bromine, which is branch. We call it branch or substituent. We call it branch or substituent. Now, what you need to do, you are going to do the numbering from where branch is nearer. So I can number it from here, and we do number only the carbon. We do numbering only carbon, not other groups. Are you getting my point,
Yes,
Mom?
sir.
Now you can see you are starting whenever you are going to write the IUPAC, you are going to write the whenever you are going to write the IUPAC, first you are going to write the name of substituent or branch. First you will write the name of substituent or branch. So you can see this is your substituent, and at what position? It is at position number 1. It is connected with carbon number 1. So you are going to write 1, and for fluoro, F we write fluoro. For Cl we write chloro. For Br we write bromo, and for iodine we write iodo. So since there is Br bromine, so we are going to write 1 bromo. Is there any other branch other than this? Is there any other branch?
No, sir.
Then you will directly jump on the parent chain. Parent chain is the number of carbon in parent chain, the longest carbon. So how many carbon is there? 3 carbon. 3 carbon is known as prop. Yes or no? 3 carbon name prop.
Yes, sir.
And since all are singly bonded, so we are going to write ane. Since all are singly bonded, we are going to write ane. Got it?
Yes, sir. Got it.
Now you are going to numbering it from 1, 2, 3. You cannot number from this directly because you are jumping in between 2 carbon. Either you are going to start from left or right. So 1, 2, 3. Now you can see the branch is at second position. So you are going to write the 2, and since it is Cl, so we are going to write 2-chloro. Then jump to the parent chain. How many carbon? 3 carbon. So it will be prop, and all are singly bonded propane. So its name will be 2-chloropropane. Got it?
Yes, sir, got it.
Now there is two branch, this branch and this branch. Now from where you are going to do the numbering? If you are going to do numbering from left side, 1, 2, 3, you will get branch at position 2 and at position 3. And if you are going to do numbering from right hand side, 1, 2, 3, so you will get branch at position 1 and position 2. So you can see from right hand side you will get branch faster or earlier than the left hand side. Yes or no? Because from the left hand side you will get the first branch at second position, and if you are going to do numbering from right hand side you will get the branch at first carbon. Isn't it nearer,
Yes, sir.
mom?
Yes, sir.
So yeah, now say numbering is very important. If you have done numbering correctly, you can write the name easily. Now you have two branches, Cl, that is chloro, and CH3, this is your methyl. Are you aware of this methyl ethyl propyl butyl? Yes or no?
Yes, sir, yes.
Yeah. Whenever you are going to write the name, you are going to do it in alphabetical order. So chloro, that start from C, and methyl, that start from M. So you know that this is at number 1. This is wrong. 3, 2, 1. You are not going to do this because numbering branches gets higher number. So you are going to write 1 chloro, 2 methyl, and then again how many carbon in the parent chain? 3 prop, and all are singly bonded propane. Again, this is very easy. 1, 2, 3, 4. I didn't do numbering from left hand side because the branch will get fourth position, and if I'm going to do numbering from right hand side to left hand side, the branch will get first position, 1 bromo butane. You know what, whenever it gets on in the first position, you can directly also write bromo butane as well. You can write here bromopropane as well. That is understood that it is the branch is at first position. Got it?
Yes, sir, got it.
Please do write it.
Yes, sir, done.
Okay, very good. Now going to give you some more questions. Uh, just wait a minute. So will you be able to understand this bond line structural formula? Yes or no? Do you understand, both of you?
No, sir.
No, sir.
No or yes, Humam?
No, no, sir.
Okay, okay, not a problem. Now, what about you, Austin?
No, sir.
Okay, so it's very easy. Basically, it's easy to write. See what happens. Just wait a minute. It's not okay. Oh man. Okay. The starting point is your carbon. The vertex, this corner is also carbon. This is also vertex, you can see is carbon. This end point is also carbon. And if it is single line, that shows it is single bond. Are you getting my point? Yes or no?
Yes, sir.
Now you can see this is the first carbon and this is the second carbon, and on the second carbon there is Br, so you are going to write Br here, and on the third carbon you can see there is Cl, so I'm going to show Cl. So basically in bond line structural formula BSF, you don't need to show, we don't show carbon and hydrogen only. Apart from this, we show all the group. So what does this mean? A carbon makes 4 bonds. So what does this mean? This carbon has 3 hydrogen because it is making only 1 bond. This carbon is making 3 bond already. That means it has 1 hydrogen. This will have 1 hydrogen. This will have 3 hydrogen. And in this way, you can easily write the name. Are you getting my point? So from here to here, you should understand what actually is bond line structural formula. Got it? Both of you?
Yes,
Yes,
sir.
sir.
So see, if you are going to write the name, this compound is very important. This compound is very important. All of the 3 is very important. Please do write the name. So, yeah, this is very important question. If you are going to do the numbering 1, 2, 3, 4 from right hand side, and if you are going to do the numbering from left hand side 1, 2, 3, 4. Basically, if you are going to see from the right hand side, substituent start from second position. And if you are going to do the numbering from left hand side, substituent starts from second position. So now both the priorities are same. Both the positions are same. Basically 2, 3 from right hand side and 2, 3 from left hand side. So which will get most, uh, which one will we be given the priority? So the one with alphabetical order. Basically, we are going to do it, the numbering on alphabetical base. So you can see bromine B. So this one from right hand side is the correct numbering. So this will be your 2 bromo, and then comes your 3 chloro, and how many carbon? 4 carbon but, and all are singly bonded butane. Very good. And if you are going to see 1, 2. So on the first position, 2 chlorine is there. So we are going to, since we have 2 same branch, so we are going to write the position 1, 1. And for 2, we are going to use di, and it will be di methyl. And how many carbon? 2 carbon. So eth, and all are singly bonded ethane. And here you can see 1, 2. This will have a name 1, 2 dimethyl ethane. Now the last, second and third question is very important because there is
So,
some, yes,
so third one is dichloro, right?
di.
Chloro.
Okay, sorry, yeah, dichloro it will be. I forgot to write. Yeah, it is dichloro because the substituent is Cl. That's why it is dichloro. Now, this has a common name, which is very important. Gem dihalide. Gem dihalide, or basically we call it geminal. And this is your vis dihalide. Vis dihalide, or we call it vicinal dihalide. Full name. Just wait a minute. Are you able to see the screen? Vicinal. So basically, when same halogens, or when halogens are present on adjacent carbon like this, that is your vicinal dihalide or vis dihalide. And when the halogens are present on the same carbon, that is your geminal or gem dihalide. Let me know when you are done with this.
Done, sir.
Very good. Mom, you are also done with this.
Yes, sir.
Please make sure you are going to make IUPAC name strong with the chapter. Very important it is. Now I'm going to write the, you're going to do some more questions. You need to first expand this and then write the name. Then it will be correct. Otherwise, it will be wrong. Please do it. Let me know when you are done with this. Or if you are not able to do it, just let me know. Are you able to solve this, Humam? Yes or no?
Not really, sir.
No problem. I'm going to explain this. Say first you are going to write in expanded form. Like this is your CH3. Hydrogen makes only one bond. That means three bond is made by this carbon and one single bond will be there with this CH2. Then after this CH is there and then there is chlorine in bracket. That means this chlorine is attached with this carbon. So it will be like this and then there was CH3. So CH3 will be like this. Now again you can see there is C and this is CH3 whole thrice. That means this all three CH3 is with this carbon. That means this carbon I'm going to write it is attached with 3 CH3. 3 CH3 and after this carbon there is CH2 and then Br as well. Now I'm going to write this C which has 3 CH3. So I'm going to write CH3 1, 2 and whole thrice is there and then Br is there. Now I'm going to write the name of all three. Now you can say if you are going to number in the first one from right hand side, the substituent will get second position, and if you are going to give numbering from left hand side, the substituent will get third position. So I'm going to number it from 1, 2, 3, 4 from left hand side, and you can see this will get on second position, and then we can write 2 chloro and in this parent chain how many carbon, 4 carbon but and all are singly bonded butane. Now from here you can see this is very important. If you are going to number it, it will be 1, 2, 3 and now you can see this is your bromo and this is your methyl, two branches there. Since you are unable to count the carbon that comes under branch, so I'm going to write the name on alphabetically 1 bromo and then at second position we have 2 methyl, so you are going to write 2 comma 2 and then dimethyl that represents 2 methyl and how many carbon in the parent chain, 3 carbon, so it will be prop or N and here you can see 1, 2, 1, 2. So there is a branch 1. No, it's wrong. Just wait a minute. You need the longest carbon, longest parent chain. So you are going to write 1, 2, 3. Because if you are going from left to right or right to left, you will get 2 carbon in the parent chain. But if you are going from top to bottom or bottom to top, you will get 3 carbon in the parent chain. So we give first priority to get maximum number of carbon in the parent chain. So in this way, you can see 2 bromo, 2 methyl, because on the second carbon, second position, you have both the branches 2 bromo, 2 methyl. And how many carbon in the parent chain? 3 carbon prop and bonded propane. In here, you can see 1, 2. Here, the branch is chlorine. So chlorine is present at first position 1 chloro. How many carbon in the parent chain? 2 carbon. So it. And since it is doubly bonded, for doubly bonded, we use ene. For singly bonded, we use ane. And for triply bonded, we use ine. So ethene. Here you can see 1, 2, 3. The priority basically varies. If functional group or multiple bond comes, we give priority to that multiple bond or functional group other than this branches. So you are not going to number from right to left here. You are going to number from left to right because double bond comes here. So you are going to write the name 3 bromo and then prop one in, because at the first position double bond is there. So mom, you need to take one class for this nomenclature from very basic. You have notes from class 11th, right? Of
Yeah,
class
yes,
11.
yes, sir.
You're going to read it, and if you get confused or anything, just let me know.
Okay, sir, yes.
Please do write it and let me know when you are done with this. Let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. I'm going to give you some questions from Benjin as well, since we haven't done any question on this. Any answer? Both of you are going to solve each and every question from NCRT. Never
Okay, sir.
leave it. Yes. Please let me know when you are done with this or if you have any problem. Humam, say what is, have you done it? This is your benzene, right? Yes or
Yes.
no?
Yes, sir.
Now you know that this is your branch, so you are just going to number it one. So at first position it is bromine, so you are going to write bromo. And what is the name of this part? Benzene. So you are directly going to write one bromobenzene. Now you just need to number it 1, 2, 3. At first position and at third position bromine is there. So 1, 3 dibromo. 1, 3 dibromo. And what is the part name of that part? That is your benzene. In the same way, can you name it? Its name will be 1, 3, 5. Since 3 comes, so tribromo. And then it's benzene. Is that clear?
Yes, sir.
Okay, please do write it and let me know. Then we will move to the next question. And after every class, you are going to give diagnostic test. Okay.
Okay, sir.
I think it will be active on app. Write the name of this some important compound CHCl3, and then you can write CHBr3, and then only three. These three. Chloroform is IUPAC name. Its name is dichloromethane. Chloroform is common name. Its name is trichloromethane, and its name is tribromo, that represents 3-bromine methane. But its common name is quite famous and very important. It has a name trichloromethane as a name. Chloroform. This will have name bromoform. And if you have CHI3, that is triiodo methane, and which one will have a common name? Iodoform. Very important reagent. Is that clear, both of you?
Yes, sir.
So this is it for today. Please do read NCERT up to